Hey everyone, and welcome back to the Deep Dive. Before we get started, make sure you hit that like button, subscribe to the channel, and click that bell icon so you don't miss out on any of our future deep dives.
That's right. We've got some exciting explorations coming up.
We do. And speaking of exciting explorations, today we're taking a trip through our cosmic neighborhood, the solar system.
A classic.
It is a classic, but it's one that never gets old, right?
Okay.
I mean, who doesn't look up at the night sky and wonder about those twinkling points of light, those other worlds out there?
Absolutely. It's a source of endless fascination.
Exactly. So, whether you're a seasoned space enthusiast, a senior school student just starting to delve into astronomy, or even a UPSC aspirant prepping for the GS1 geography paper, this deep dive is going to be your guide to understanding the planets that share our celestial home.
I think it's safe to say that there's something here for everyone, no matter their level of expertise.
Definitely. Okay, so let's start by setting the stage. Imagine, if you will, our solar system. You've got this blazing sun at the center, right? And then these 8 fascinating planets, each with its own unique story to tell, revolving around it.
It's kind of like a cosmic dance, isn't it? Each planet following its own choreographed path around the sun.
I like that, a cosmic dance. So in this dance, we've got our star players: Mercury, Venus, Earth, our home sweet home Mars, then the mighty Jupiter, the ringed beauty Saturn, and last but not least, the mysterious ice giants, Uranus and Neptune.
A pretty impressive lineup, wouldn't you say?
Absolutely. But here's the thing. It's not just a random collection of celestial objects. There's an order to it, a system. And that's what makes studying the solar system so fascinating.
It's like piecing together a giant puzzle. The more we learn about each planet, the better we understand how our solar system formed, how it evolved, and ultimately our own place within it.
Exactly. So how do scientists actually go about making sense of all these celestial objects?
Well, they don't just lump them all together, that's for sure.
Right, right.
There's a system to the classification, and it's based on some key characteristics. The most basic distinction is between what we call terrestrial planets and Jovian planets.
So like Earth-like versus Jupiter-like.
Exactly. Think of it as rocky versus gassy.
Okay, I can get on board with that. So what makes a planet Earth-like? Fill me in.
All right, so the terrestrial planets are the ones closer to the sun. These are Mercury, Venus, Earth, and Mars. They're relatively small, dense, and composed mostly of, as the name suggests, rock and metal.
So they're the solid rocky planets. Got it.
Precisely. Now, the Jovian planets, these are the big guys, the giants of our solar system: Jupiter, Saturn, Uranus, and Neptune. They're much further from the sun, and their composition is, well, it's mostly gases like hydrogen and helium.
Ah, so that's why we call them gas giants.
You got it.
But hold on, gas giants. I mean, doesn't that make them sound like, well, giant fluffy clouds? Are they really just big balls of gas?
That's a common misconception. While they do have these incredibly thick atmospheres dominated by hydrogen and helium, deep down we believe they have solid cores. And of course, let's not forget those stunning rings, especially prominent around Saturn, composed of ice and rock particles. Those rings are like a cosmic fingerprint, unique to each Jovian planet.
Okay, that clears things up a bit. So we've got the rocky, Earth-like planets closer to the sun and these massive gas giants further away. But why? Why are they so different? I mean, they all formed from the same swirling cloud of dust and gas, right?
Right, in the early solar system. It's a great question, and the answer lies in understanding how planets form and the different factors that influence their evolution. Things like their distance from the sun, the impact of solar winds, and the role of gravity all play a part in shaping a planet's destiny.
Okay, I'm intrigued. Tell me more about how these factors shape the planets as we know them today.
All right, so picture this. The early solar system, a swirling cloud of dust and gas, right? As the sun ignites at the center, it starts exerting its gravitational pull, causing the surrounding material to clump together. Now, the closer this material was to the sun, the hotter it got.
So the early Earth was basically a scorching hot mess.
You could say that. Only materials with high melting points, like rock and metals, could withstand that intense heat. They formed the solid cores of the terrestrial planets. But the lighter elements, the gases, they were literally blown away by these powerful solar winds, which are basically streams of charged particles emanating from the sun.
So the inner solar system was like this cosmic oven baking those rocky planets. But what about further out, where the gas giants formed?
Out there, it was a different story altogether. Temperatures were much cooler, so gases like hydrogen and helium could condense and form these massive planets. Their own strong gravitational pull allowed them to hold on to these massive atmospheres, which is what makes them the gas giants we know today.
Wow, so distance from the sun really was a game changer. It shaped the planets in such a fundamental way. Being close to the sun made the terrestrial planets what they are, and being farther away allowed the gas giants to form.
Exactly. Distance is a key factor in planetary formation and evolution. And speaking of distance, have you ever heard of the Goldilocks zone?
Oh yeah, the Goldilocks zone. It's like that fairy tale, right? Not too hot, not too cold, but just right.
Exactly. In astronomy, the Goldilocks zone refers to that sweet spot around a star where the temperature is just right for liquid water to exist on the surface of a planet. It's often called the habitable zone because, well, as we know, liquid water is pretty crucial for life as we know it.
Right. Earth being in the Goldilocks zone is what allows us to have oceans and all this amazing life,
You
right?
got it. If a planet's too close to its star, any water would just evaporate. Too far, and it would freeze solid. The Goldilocks zone is that perfect balance where conditions are just right for liquid water and potentially life as well.
Which makes me wonder, are there other Goldilocks planets out there orbiting other stars?
Yeah.
Could they harbor life?
That's a question that keeps astronomers up at night. The search for exoplanets, planets outside our solar system, especially those within their star's habitable zone, is a hot topic right now. The possibility of finding another planet teeming with life is, well, it's incredibly exciting.
Yeah, that would be a game changer. It's mind-blowing to think about all the different kinds of worlds that might exist out there. But for now, let's bring our focus back to our own solar system and dive into some of the specifics. We've got 8 planets to cover, each with its own unique story. So starting with Mercury, the closest to the sun, what makes this planet stand out?
Well, Mercury is kind of an oddball. It's the smallest planet in our solar system, and it's also the fastest, zipping around the sun at an incredible speed. It takes only 88 Earth days for Mercury to complete one orbit.
Wow, so a year on Mercury is less than 3 months long. That's crazy. But being so close to the sun, I imagine it must be incredibly hot there, right?
You're absolutely right. Mercury experiences some of the most extreme temperature variations in our solar system. The side facing the sun can reach a scorching 800 degrees Fahrenheit, but the side facing away, it plummets to a frigid negative 290 degrees.
Whoa, talk about a temperature swing. I
Right.
wouldn't want to be caught without my sunscreen A&D parka on Mercury. And speaking of extreme conditions, Mercury actually has something in common with our moon,
You're thinking about its lack of a substantial atmosphere.
right?
Exactly. Mercury has an incredibly thin atmosphere, almost negligible, which means there's no weather to speak of, no wind or rain, and without an atmosphere to trap heat, those temperature swings are even more dramatic.
It's fascinating how the presence or absence of an atmosphere can make such a huge difference. Speaking of atmospheres, let's move on to Venus, often called Earth's twin.
Yes.
What makes Venus so similar to Earth, yet so different?
Venus is similar to Earth in size and density, but that's where the similarities end. It's shrouded in this incredibly thick, toxic atmosphere, composed mainly of carbon dioxide with clouds of sulfuric acid. And this dense atmosphere, it traps heat, creating a runaway greenhouse effect.
A runaway greenhouse effect. It doesn't sound good.
It's not good for life as we know it, that's for sure. It means Venus is the hottest planet in our solar system, even hotter than Mercury, even though it's farther from the sun. The surface temperature can reach a staggering 900 degrees Fahrenheit, hot enough to melt lead.
Yikes, that is hot. And those sulfuric acid clouds don't sound too inviting either.
No, not at all. Venus is definitely not a place for a casual vacation. And to top it off, Venus has another peculiar quirk. It rotates extremely slowly and in the opposite direction of most planets. So a day on Venus is actually longer than its year.
Okay, Venus is definitely off my list of potential vacation spots. It sounds like a pretty hostile and unforgiving world, which makes me appreciate our own planet Earth even more. What makes Earth so special besides being, well, home?
Earth really is unique. First and foremost, it's the only planet we know of that supports life. As we discussed earlier, its position in the Goldilocks zone, the presence of liquid water, a protective atmosphere, and a relatively stable climate all contribute to making it a haven for life.
And let's not forget Earth's incredible diversity, from vast oceans and towering mountains to lush forests and scorching deserts, icy glaciers and vibrant coral reefs.
Absolutely. It's a dynamic and constantly evolving planet shaped by geological processes, weather patterns, and the interactions of living organisms. Truly remarkable. And understanding our own planet better helps us appreciate the delicate balance that makes life possible.
Well said. Now let's hop over to our next-door neighbor, Mars. It's the planet that has really captured the human imagination for centuries. What makes Mars so intriguing, and what have we learned from all those robotic explorers we've sent there?
Mars is often called the red planet because of its rusty red surface. That's caused by iron oxide, or rust, in the soil. It's smaller and colder than Earth, with a thin atmosphere, about 100 times thinner than Earth's. But despite those harsh conditions, Mars is the most Earth-like planet in our solar system, and that's what makes it so fascinating.
I've always been intrigued by the idea that Mars might have once been a much warmer and wetter planet, potentially even harboring life. Is there any evidence to support that?
There is. We've sent numerous missions to Mars, starting with the Mariner probes way back in the 1960s, and more recently with the rovers that are exploring the surface right now. These missions have revealed compelling evidence that Mars once had flowing water on its surface, possibly even vast oceans.
Liquid water on Mars, the key ingredient for life as we know it. That's amazing. What kind of evidence are we talking about?
We're seeing signs of ancient riverbeds, lake beds, even possible shorelines. Some Martian rocks have mineral compositions that form only in the presence of water. And the rovers have even found rounded pebbles shaped by the tumbling action of water.
So, Mars was once a much more dynamic, possibly even habitable planet than it is today. What happened? Where did all that water go?
That's a question that scientists are still trying to answer definitively. The leading theory is that Mars lost its magnetic field, which protected its atmosphere from being stripped away by solar wind. As the atmosphere thinned, the planet lost its ability to hold on to liquid water, and, well, it gradually became the cold, dry desert we see today.
It's a reminder that planets are constantly evolving, and what we see today is just a snapshot in their long and complex history. But even though Mars might not have oceans anymore, it still has the potential for harboring life, right?
That's right. Scientists are particularly interested in the possibility of microbial life existing beneath the Martian surface, where it would be shielded from the harsh radiation and extreme temperatures. The search for signs of past or present Martian life is one of the most exciting frontiers in space exploration.
And who knows, maybe someday humans will set foot on Mars and explore its secrets firsthand. But for now, let's leave the red planet and journey out to the realm of the gas giants, starting with the king of planets, Jupiter. What makes Jupiter so majestic, and what sets it apart from all the other planets in our solar system?
Jupiter is a true behemoth. I mean, it's the largest planet in our solar system, more than twice as massive as all the other planets combined. It's a gas giant composed primarily of hydrogen and helium, and its atmosphere, it's this swirling tapestry of colorful bands and storms, including the iconic Great Red Spot.
The Great Red Spot, a storm that's been raging for centuries, right? And it's bigger than Earth.
It is. It's a testament to Jupiter's immense size and powerful atmospheric dynamics. And aside from its sheer size and wild weather, Jupiter has another impressive feature: its moons.
Oh yeah, Jupiter's a lot of moons, right? Dozens.
79 confirmed moons, to be exact. That's more than any other planet in our solar system. And some of these moons, they're pretty remarkable in their own right.
Like miniature planets.
Exactly. For instance, there's Ganymede, Jupiter's largest moon. It's actually bigger than the planet Mercury. And then there's Europa, a moon covered in an icy shell that scientists believe hides a vast ocean of liquid water underneath.
A moon with a hidden ocean. Now that is incredible. Are scientists considering Europa as a potential place to look for life?
Absolutely. Europa is considered one of the most promising places in our solar system to search for extraterrestrial life. That subsurface ocean could hold more water than all the oceans on Earth combined. And the tidal forces from Jupiter, they could generate heat, keeping that water liquid.
So Jupiter itself might not be a hospitable place for life, but its moons could be a different story altogether. They might hold the key to answering one of humanity's biggest questions. Are we alone in the universe?
It's a tantalizing possibility, that's for sure. And it's one of the main reasons why there's so much focus on exploring Jupiter and its moons. But speaking of fascinating moons, we can't forget about Saturn, the ringed wonder of our solar system. I mean, those rings, they're iconic.
They are iconic. I remember the first time I saw Saturn's rings through a telescope as a kid. It was breathtaking. What are those rings made of, and how did they even form?
They're made of billions, and I mean billions, of icy particles, ranging in size from tiny grains of dust to chunks as big as houses. And they orbit Saturn in this thin disk, creating a spectacle that's visible even from Earth with a small telescope.
It's amazing to think that something so beautiful and intricate is made up of countless tiny particles.
It really is. And as for how they formed, well, there are a few theories. The most widely accepted one is that the rings are the remnants of a moon, or maybe even a comet that got too close to Saturn and was torn apart by its powerful gravity.
Saturn's gravity is so strong that it can shred moons into pieces. That's kind of terrifying, but also incredibly awesome.
It's a testament to the incredible forces at play in our solar system, and like Jupiter, Saturn has a large family of moons. 82 confirmed so far, some of which are just as intriguing as Jupiter's moons.
Intriguing, huh? I'm sensing you're about to drop some more knowledge on us.
I am. I'm talking about Titan and Enceladus. Titan, Saturn's largest moon, is the only moon in our solar system known to have a dense atmosphere. It's so dense that it actually obscures the moon's surface from view. And beneath that thick atmosphere, Titan has lakes and rivers. But here's the kicker. They're not made of water, they're made of liquid methane and ethane.
Liquid methane. That sounds like something out of a science fiction novel.
It does, doesn't it? Titan is truly a world unlike any other we've seen, and it's a prime target for future exploration. Then there's Enceladus, a smaller moon that's completely covered in ice. But it's got these geysers, plumes of water vapor, and ice particles that erupt from its south polar region.
So there's something going on beneath that icy shell, right?
Exactly. Those plumes are a sign that there's a subsurface ocean beneath the ice. And where there's water, well, there could be life.
Wow, so both Titan and Enceladus, with their very different but extreme environments, are potential candidates for life. That's amazing.
It just goes to show that our definition of habitable is constantly evolving as we learn more about the incredible diversity of worlds out there. And that's what makes exploring our solar system so exciting. It's the constant potential for discovery, the realization that we're just scratching the surface of what's out there.
Well said. We've still got 2 more planets on our solar system tour those icy giants, Uranus and Neptune. They're the farthest planets from the sun, and they're shrouded in mystery. But we'll delve into their fascinating stories in the next part of our deep dive. Stay tuned.
Welcome back, space explorers. We're picking up right where we left off, venturing out to the realm of the ice giants, Uranus and Neptune.
The farthest planets from the sun, right?
Right. And they're truly worlds apart, these ice giants. They're different from the gas giants like Jupiter and Saturn in some key ways.
Okay, I'm ready to dive into these icy depths. What makes them so different from, say, Jupiter and Saturn?
Well, think about composition. Jupiter and Saturn are mostly hydrogen and helium, the lightest elements. But Uranus and Neptune, they have a higher proportion of heavier elements. Things like oxygen, carbon, nitrogen, and sulfur.
So they're not just giant balls of ice like, ice cubes.
Not exactly. These ices aren't like the ice we're used to here on Earth. It's more like this really dense, almost slushy fluid mixed with rock and gas.
So imagine a giant swirling cocktail of ice, rock, and gas.
There you go. That's a pretty good way to picture it.
Okay, I'm getting a sense of these ice giants. Let's start with Uranus. What's the story with this planet?
Uranus is unique because it's tilted on its side. You know how most planets spin like tops, right? Their axis of rotation is, roughly perpendicular to their orbit around the sun.
Yeah, like Earth?
Exactly.
Yeah.
But Uranus, its axis is almost parallel to its orbital plane. So it's like a ball rolling around the sun instead of spinning like a top.
That's so strange. What could have caused a planet to tip over like that?
The leading theory is that early in its history, Uranus had a massive collision with another object, maybe a planet-sized body. And that impact was so powerful that it basically knocked Uranus on its side.
Wow, that must have been some impact. What are the effects of this unusual tilt? I mean, does it affect Uranus in any noticeable ways?
It definitely does. It gives Uranus the most extreme seasons in the entire solar system. Each pole experiences decades of continuous sunlight, followed by decades of darkness. So imagine a summer that lasts 42 Earth years, followed by a winter of the same length.
Talk about extreme weather. I'm definitely happy with our more moderate seasons here on Earth. But what about Uranus's atmosphere? Is it as stormy and turbulent as Jupiter's?
Actually, Uranus is pretty calm compared to Jupiter. It has a hazy atmosphere, mostly hydrogen and helium, with traces of methane, which is what gives it that pale blue-green color.
So it's a pretty chill planet compared to Jupiter's raging storms.
Relatively speaking, yeah. And it does have rings, but they're much fainter and less prominent than Saturn's. They're made of these really dark particles, probably a mix of rock and ice.
Okay, so Uranus is the tilted blue-green ice giant with faint rings. Check. Now, what about Neptune? What sets it apart from its icy sibling?
Well, Neptune is similar to Uranus in composition and size, but it has a much more dynamic atmosphere. In fact, Neptune boasts some of the fastest winds in the entire solar system. We're talking speeds exceeding 1,200 miles per hour.
Wow, that's faster than the speed of sound. What causes such powerful winds on Neptune?
Scientists think those winds are driven by the internal heat escaping from Neptune's core. And remember, Neptune's way out there, super far from the sun, so even small temperature differences in its atmosphere can create powerful convection currents, and those drive those incredible winds.
So Neptune is like this giant heat engine churning up those powerful winds. Pretty cool.
Definitely. And like Uranus, Neptune has that bluish color due to the methane in its atmosphere, but Neptune's blue is deeper, richer, which I think adds to its mystique.
It sounds absolutely breathtaking.
Yep.
So what about rings? Does Neptune have those too?
Yes, Neptune has rings, but they're even less prominent than Uranus's rings. Faint, made of dust and ice particles. And we think they're relatively young, maybe formed from the debris of a moon that got shattered.
So both ice giants have rings, but they're just not as flashy as Saturn's. It's amazing how each planet has its own unique set of characteristics.
Absolutely. Each one is a world unto itself, shaped by its formation and its evolution and the complex interplay of all these forces in our solar system. But we're not done with unique worlds yet. Let's talk about a region beyond Neptune that's home to a whole bunch of fascinating objects. The Kuiper Belt.
The Kuiper Belt. I always think of it as like the solar system's attic, full of, icy remnants from its early days.
That's a great analogy. The Kuiper Belt is this vast region that extends beyond Neptune, and it's filled with icy bodies, comets, and dwarf planets. It's like a cosmic time capsule, preserving material from the early solar system.
And this is where we find Pluto, right?
Yeah.
The former ninth planet that got demoted.
Yes, Pluto is probably the most famous resident of the Kuiper Belt. It was considered the ninth planet for decades, but in 2006, the International Astronomical Union, or IAU, reclassified it as a dwarf planet.
I remember that caused quite a stir. Why did they demote Pluto? It seemed kind of harsh.
Well, the IAU established a new definition of what constitutes a planet, and Pluto didn't meet all the criteria. One of the key criteria is that a planet has to clear its neighborhood. Basically, it has to be gravitationally dominant in its orbital zone. Pluto, it shares its orbit with other similarly sized objects in the Kuiper Belt.
So Pluto got demoted for having too many neighbors.
You could say that, but it's all about scientific classification, right?
Yeah.
Making sure our definitions are consistent and meaningful. Pluto's still an incredibly fascinating and important object in our solar system. It just falls into a different category now, a dwarf planet.
And it's got company out there, right? There are other dwarf planets in the Kuiper Belt?
That's right. Eris, Makemake, and Haumea are a few examples. They're smaller than the 8 major planets, but they're still big enough to be rounded by their own gravity.
It's mind-boggling to think about all these icy worlds out there, beyond Neptune, just waiting to be explored.
Absolutely. It's a reminder that our solar system is vast, complex, and full of surprises. But hold on, because we're not done yet. There's one more region beyond the Kuiper Belt that's even more mysterious and enigmatic. I'm talking about the Oort cloud.
The Oort cloud? Okay, I'm intrigued. What's that all about?
The Oort cloud is like a giant spherical shell of icy objects, and it's thought to extend out tens of thousands of astronomical units from the sun.
Tens of thousands. That's mind-bogglingly far.
It is. Remember, 1 astronomical unit, or AU, is the average distance between the Earth and the sun. So the Oort cloud is really at the edge of our solar system, the very fringe.
What's out there in this Oort cloud?
It's thought to be home to trillions of icy objects, remnants from the earliest days of our solar system. These objects are so far away and so faint that we haven't actually directly observed any of them yet.
So it's like this giant, invisible sphere surrounding our solar system, filled with icy relics from the past.
Precisely. And while we haven't directly observed any Oort cloud objects, we believe they're the source of long-period comets, the ones that occasionally grace our skies.
So those comets that streak across the night sky, some of them might have originated in the Oort cloud, billions of miles away.
That's right. These long-period comets can take hundreds or even thousands of years to complete one orbit around the sun. They're like messengers from the outermost reaches of our solar system.
It's incredible to think about the vastness of our solar system and all the mysteries it still holds. But we've covered so much ground already, from Mercury to the Oort cloud. What's next on our solar system adventure?
Well, next, I think it's time to shift gears a bit. We've talked about the planets, the dwarf planets, the icy objects. But how do we know all this? How have we uncovered these secrets of the solar system? I think it's time to delve into the stories of the incredible missions that have ventured out to explore these distant worlds.
Sounds good to me. From the Voyager probes to the Mars rovers, there are so many fascinating missions to explore.
Exactly. So buckle up, space enthusiasts. We're about to embark on a journey through the history of space exploration. Stay tuned.
Welcome back for the final leg of our solar system journey. I feel like we've already covered so much ground, from the scorching surface of Mercury to those icy objects way out in the Oort cloud.
We have. It's been quite a tour, hasn't it? From the inner solar system to the outer reaches and everything in between.
It really has. But none of this knowledge, none of these incredible insights would be possible without those amazing missions that have ventured out to explore these worlds, right?
Absolutely. These missions are a testament to human ingenuity, our drive to explore, to understand our place in this vast cosmos. They've brought us breathtaking images, groundbreaking discoveries, and a wealth of data that's completely reshaped our understanding of the solar system.
So let's take a trip down memory lane, revisit some of those iconic missions that have helped unlock the secrets of our planetary neighbors. Where should we start? Any favorites come to mind?
Well, it's hard to talk about space exploration without mentioning the Voyager missions. Voyager 1 and 2 launched back in 1977. They embarked on this grand tour of the outer solar system, flying past Jupiter, Saturn, Uranus, and Neptune. And along the way, they captured some of the most stunning images we have and collected tons of invaluable data.
Voyager 1 and 2, they're like the interstellar pioneers, venturing out into the unknown, sending back postcards from the edge of our solar system.
That's a great way to put it. They really are. And they've made countless groundbreaking discoveries. Think about it. Active volcanoes on Jupiter's moon, Io, the intricate structure of Saturn's rings, the complexity of Uranus and Neptune's atmospheres, all thanks to the Voyagers.
And did they also carry a message for any extraterrestrial civilizations that might encounter them?
They did. Each Voyager spacecraft has a golden record on board. And on that record, you'll find sounds and images of Earth. A sort of time capsule, a representation of humanity and our planet.
A message in a bottle, cast out into the vast cosmic ocean.
Exactly. Hoping to make a connection, however small, with any intelligent life that might be out there.
It's both beautiful and humbling at the same time. It shows that even as we explore the universe, we're also looking for connection, a sign that we're not alone.
Exactly. And while the Voyagers are continuing their journey into interstellar space, which has become a prime target for exploration.
Mars, the red planet. It seems to hold a special fascination for us. Maybe it's because it's the planet most similar to Earth in a lot of ways.
It's definitely fueled countless dreams of human exploration and even, colonization someday.
Yeah.
And the missions we sent to Mars, they've only intensified that fascination.
We've said a lot, haven't we?
We have. Think about it. From the Mariner probes back in the 60s to the rovers that are actively exploring the surface right now, we've sent a flotilla of robotic explorers to Mars. And what have we learned? Well, it turns out Mars wasn't always the cold, dry desert it is today.
All right. The evidence suggests that Mars was once a much warmer and wetter place.
Exactly. There's evidence of ancient rivers, lakes, maybe even oceans. Those rovers have found rounded pebbles, those layered rock formations you only get in the presence of water, and even mineral deposits that require water to form.
So Mars was once more Earth-like, potentially even habitable. That's incredible.
The evidence is pretty compelling, and the rovers have even detected organic molecules in the Martian soil.
Organic molecules, the building blocks of life.
Yes. It's pretty amazing, isn't it?
It makes you wonder if life ever existed on Mars, or if it might still exist somewhere beneath the surface.
Those are the questions driving a lot of the current research and exploration. Scientists are using the rovers to search for signs of past or present Martian life.
It's exciting to think that we might be on the verge of answering one of the biggest questions in science. Are we alone in the universe?
Absolutely. And it's not just about Mars. There was the Cassini-Huygens mission that spent 13 years orbiting Saturn and its moons.
Cassini-Huygens, it was like a cosmic ballet, right?
Yeah.
Gracefully orbiting Saturn, those incredible rings, and sending back those breathtaking images.
It was a remarkable mission. Cassini mapped Saturn's rings in detail, discovered new moons and rings, and even sent a probe, Huygens, to land on the surface of Titan.
Titan, the one with that super dense atmosphere and the lakes and rivers of liquid methane.
The one and only. And what did Huygens find? Well, it sent back images of a landscape that looked eerily familiar. River channels, shorelines, dunes, all sculpted by liquid methane instead of water.
That's wild. It's like something out of a science fiction story.
I know, right? And Cassini's observations of Titan, well, they revealed this incredibly complex world with weather patterns, seasons, and even possible cryovolcanoes.
Cryovolcanoes, volcanoes that erupt with ice.
Exactly. It just shows you how diverse the universe is. We're constantly discovering new and amazing things, things that challenge our assumptions about what's possible.
It's mind-blowing. And all these incredible missions, they're just the beginning. There's so much more to explore.
Absolutely. We've got the James Webb Space Telescope, which is already transforming our view of the universe, and there